Afternoon, Vanadal, and this is Anjan from EC department. Next, we have to discuss about IIR digital filter and this complete regarding third unit. After third unit, we discuss about the fourth, and that is FIR filter. FIR filter and IIR filter. These two filters came from different types of discrete time systems. Clear? The types of discrete time systems have 6, I think. First one is the stable and unstable, and second one is the linear time invariant, time variant. Next, causal and non-causal. Next, stable and unstable, and next FIR and IIR. Next, these 6 are the types of discrete time system. In that, one type of discrete time system is FIR and IIR. From that discrete type system, FIR has a separate unit, IIR has a separate units also. In this, we are discussing about IIR digital filters. What is IIR and what is FIR? That should be 2 definitions are there. We go for first IIR. Definition is the impulse response is infinite duration. If the impulse response is infinite duration, then the system is to be infinite impulse response. Okay, next go for FIR filter. In that, the impulse response is finite duration. The impulse response is finite duration, then the system is to be FIR filter. Here, discussing about IIR filter. Why? Because FIR filter has separate unit, that is discussed later. Okay. Basically, a digital filter is a linear time invariant system only. Next, the IIR and FIR are used to distinguish filters types. So that's why we are using different types of filters are used. Clear? Next, to go for FIR filters. So small announcement of FIR is where FIR filters are of non-recursive type. That means the present output samples depends on the present input samples and previous input samples also. This should be regarding FIR filters. This is discussed later. Just you go for IIR filters. So these IIR filters are recursive type of filters. In this, the present output samples depends on the present input, past input and past output samples also. So this is regarding about IIR filter. Okay, the main important 2 formulas are there. That is the impulse response H of n for a realizable filter is H of n should be is equal to 0 for n less than or equal to 0. And this equation has a stability condition. Okay, that condition is very, very important in our DSP. That is summation of n is equal to 0 to infinite. So modulus of H of n less than infinite. This should be is in a positive or negative, whatever it may be. So that's why I'm taking here model. Okay, that's why I'm taking modulus. If it is positive, if it is negative, whatever it may be. Summation n equals 0 to infinite. Modulus H of n is less than infinite. This is very important condition. Whenever the impulse response is exist in this condition, then impulse response satisfy a stability condition. Clear? Next, this is very, very important equation. So the transfer function of IIR digital filters have in this format. H of z, capital H of z, it should be is equal to summation n equals 0 to infinite, small h of n z power minus n. This is in the form of Z transform. So simply I'm saying the Z transform of impulse response is the transfer function of IIR digital filter. Once again I'm saying the Z transform of impulse response is the transfer function of IIR digital filter. Clear?